morning, friends. Now we are discussing module number 3. So that is solar energy in energy engineering. So to overcome the dependency on the conventional fuels, so researchers and many organizations are working on the alternative fuels so that they are commercially viable, so easy to use, and they are producing less pollution. And these alternative fuels must be available abundantly in the nature. So in this direction, so renewable energies like solar energy, wind energy, then tidal energy, so biofuels, and many more non-conventional and renewable energy resources. The studies are going on to capture these non-conventional source of energy. So these forms may not only renewable, but also maintaining the ecology and environment, because they are so much eco-friendly and do not contribute to the global warming and will not produce greenhouse gases. So the renewable energy resources will be classified like this. So solar energy, so that is further classified as solar thermal and solar photovoltaic. Then we have wind energy, so biomass energy. So then hydro power energy. So then we have the tidal energy. So that is the waves, the moving waves of the oceans. So then geothermal. So these are renewable energy resources. So the sun is the source of vast majority of the energy what we use on the earth. So most of the energy we use will undergo various transformations before it is finally utilized. But it is possible to tap this solar energy as it arrives on the earth's surface. So solar energy, we can say it as the energy which is produced directly by the sun and collected elsewhere on the earth. So the sun will create its energy through the process called thermonuclear process, which is converting about 65 crores tons of hydrogen to helium every second. So this is thermonuclear process. So this process will generate heat and electromagnetic radiation. So this electromagnetic radiation is consisting of visible light, infrared light, ultraviolet radiation, which is streaming out into space in all the directions. So where and all the solar energy will be finding its uses. So it will be used for heating or cooling the residential buildings. So during winter, so the residential here building will be getting heated up, and during summer, so it will be getting cooled using solar energy. So water heating is the main application found in residential buildings, and electric power generation. So heating the water and electricity generation. So these are the two major applications. Apart from this, we have solar cookers, and using the suitable solar dryers, we are drying the agricultural and animal products. Then food refrigeration. So the perishable food items need to be maintaining the moderate temperature, so that the food will be in the safe condition for quite longer time. So we're converting solar energy into electricity by using photovoltaic cells. Then we have solar farms. Then wind energy is also one indirect source of solar energy. So there will be existing two main components of the solar radiation. So one is the beam radiation, the other one is the diffuse radiation. So beam radiation is nothing but the solar radiation directly received from the sun without scattered by the atmosphere. So direct radiation. So that is the sun beam. What is directly received on the earth surface is beam radiation. Whereas diffuse radiation is the one that is received from the sun after its direction has been changed here, right, by scattering by the atmosphere. So we have the diffuse radiation. So direct beam is received by some solar radiation equipment. So this is the beam radiation. So the sun beam which is getting scattered by the atmosphere at a different angles. So then received by the solar radiation equipment. So will be the diffuse radiation. So we have two major solar radiation measuring equipments. One is pyranometer. So that the second one is pyrheliometer. So pyranometer. So it is the instrument used to measure the global solar radiation on the surface. Broadly speaking, we have two types of pyranometers. Although they are doing the same job, but their working principle is quite different. So thermopile type pyranometers will measure the sunlight from the heat it is generating. So, what is the amount of heat generated from the sunlight? So, based on that, so this thermopile type pyranometer is going to calculate how much of sunlight is effectively used. But whereas the chip type of pyranometers will measure the sunlight by calculating how much of electricity is generated. So thermopile type will measure the sunlight based on how much heat is generated from the sunlight, whereas the chip type pyranometers will measure the sunlight from the quantity of electricity it is generating. What they measure is the solar radiation that is falling on the horizontal surface in watts. That is the amount of energy received each second. So that is per square meter, watts per meter square. So technically that is known as insolation. Insolation is nothing but the solar radiation, that is the measurement of solar radiation falling on the horizontal surface measured in terms of watts per square meter.